Welcome. I'm guessing if you're watching this, it's because you missed class today, although maybe not. Maybe you just want to get a little extra review. But what we talked about and what you should be generally doing if you can't make classes to watch these ed puzzles after. I did first and fifth period class today, and largely the questions that came up there are the questions that you would have. There may be some extra stuff here that we didn't do, and then I'm going to probably leave out some things that we did in class. I can't do everything. And I'm going to try to definitely keep this lesson 10, maybe to 5 minutes, but probably more like 10. Anyway, we're talking about probability now. We just started, which when we say about probability, we're talking about likelihood or chance of something that's going to happen. Typically, most people refer these from like 0% to 100%, like there's a 0% chance that's going to happen, no chance, versus 100% chance, definitely going to happen. But in reality, oftentimes the probability is expressed as a number from 0 to 1. It's a decimal. So like flipping a coin, you would say that's what? Yeah, you'd say it's 50% probably, but a lot of times that might be written as 0.5%. Or maybe something's kind of likely to happen, but not exactly likely to happen. You may say, well, that's, maybe 77% somehow. You got a number. And so that could also be written as 0.77. Notice we're just moving into decimal places, 2 places to the right or 2 places to the left to convert back and forth. Something that's not very likely to happen, maybe you've got something that's like only got a 10% chance of happening, 10%, okay? Which we could also write as 0.1. Notice these are always from 0 to 1. I want to make sure you're clear. If you ever see something written like this, 0.10%, you should really think twice around what that person meant. Did they write it correctly? Because this is very, very unlikely to happen. This right here is almost no chance of happening because it's actually, if I was going to convert it to a decimal, it's 0.001%. So notice the difference there. This is still very unlikely, but this is even more unlikely. So when you get something that's less than point something in percent, it's probably written correctly, but it may be that somebody didn't know what they were doing and they kind of mix and match the two. So it's just worth thinking about. What you were supposed to do, what you're supposed to be doing in the next few weeks, excuse the dog, as we do this is you're supposed to be going through the problems that I give you the day before in the book, and then that might require you to do some reading, and you don't need to stress about those, but it's better for class if you've looked at them before. So if we go to Google Classroom, and I go into fifth period from today, you will notice that there is a link to a practice set. And when I click on that, it opens up some problems. The first probably 3 to 4 problems are going to have to do with what we just did in the lesson. And then beyond that, somebody was asking about radians today. We actually haven't done radians. So when you get to these later problems, they're probably review problems. They're definitely worth looking at. But I wouldn't stress about them. I would read them and see if you know the answer, but if you don't, I wouldn't stress out about them, because what we care about most are the first like 3 or 4 problems, which are probability. So the first problem here was, what's the probability of a spinner landing on the section labeled G? So I'll let you look at that and think about it for a second. So likelihood of landing on G, this happens to be multiple choice, and you probably already figured out that yes, it is in fact 1/4 or 25%. Once again, it's 1/4 of the circle, so that's why. The next one is how likely or how many times would you expect the spinner to land on B if you were spinning this around? And so I told people just to write in the chat window, like, how would you figure that out? And several people usually responded, well, it's 1,000 spins divided by 6, because he's equally likely to land on any one of those sectors, or equally sliced slices. Some people said, well, it's 1/6 of 1,000, which is also correct. So this is probably review. The last question I'm going to go back to in a minute, but let's say you got to something and you weren't quite sure what it was. The other thing you should consider doing is the second link that I provide is actually the lesson itself. And this first lesson was pretty simple, so I didn't think people really needed to look at it. And I would scroll down first to read the summary. If you read the summary, it tells you probably most of what you need to know. And if you're still a little confused, you could probably scroll back up and maybe read some of the beginning material. I would skip over this first one's usually a warm-up. But this section in the middle here usually kind of walks you through some of the basic concepts. And the idea is after you spent 20 minutes or so doing that, sorry for the dog again, you would then bring your questions to class. So I got two more things I want to talk about. So one of the questions in there was about a true-false test and how likelihood it would be if you had just a random true-false test, you do know the answers, and what's the likelihood with two questions that you would answer both of them correctly, and what's the possibility of you answering exactly one right answer? So you got two questions. So I'm just going to say to begin with, let's pretend the key to this is the first one's true and the second one's false. Well, what's the likelihood that you're going to guess true then false? Well, sometimes it's helpful to list out what's called the sample space. The sample space are all the possible things that can happen when you're running what's called an experiment or a trial. So what could happen? Well, I could write true, true. I could write false, false. I could write true, false, or I could write false, true. If I'm answering the two questions, those are kind of my possibilities. That's my sample space. The event is what actually happens or what I actually do. But if we just look at that, well, what's the chance of me, if this is the key, this was actually the correct answer, we just made that up. But let's say, well, there's only one of those, there's true, false. There's a 1 in 4 chance of this happening. So the probability of me doing the correct answer, and this is one way you write a correct answer, the probability of that is, 1 over 4. Or I could write this, oops, I'm off the screen. It's 1 over 4, or it's 0.25, or it's 25%. Those are all correct answers. Now the other one's a little trickier. It's what's the chance of getting exactly one right? So the probability of exactly one right. My dog's going to bark again. Well, here's the thing. First one's true. So that's the first one right. So there and there. Second one's false, which is there and there. Now, this is 3 out of 4 if you're not paying attention. It's 3 out of 4 chance of getting at least one right. But the question was exactly one right. So this one with the key on it, which is this one right here, this one doesn't count because it doesn't match up with my success status for this thing. So I got 2, if I do true, true, I got the first one right. If I do false, false, I got the second one right. So the probability of that is 2 out of 2 things that can happen out of a sample space of 4 of 1 or 1/2 or 50%. All I'm going to do is I'm going to show you a couple of other questions I've written that you might want to look at, and you can try them. But otherwise, that's plenty. So let me throw up a few other questions that I wrote, and you can freeze the screen and try them on your own if you like to. I just have to find them. Here we go. So assuming it doesn't take too long to load, that would be super annoying. And if that actually takes super long, we may just be done. Oh, there we go. Okay, I'm going to read them real quick, and then I'm going to be done. So question 1. I'll try to get in as close as I can. There is one multiple choice with 5 answers. You have no idea which answer is correct. If you pick option E, what is the likelihood that you will get it correct? Write your answer as both a decimal and a percentage. Second question, another multiple choice question. You realize that Mr. Taylor has made up two ridiculous words as distractors. If this question has 5 choices and you avoid the ones you know are incorrect, what is the likelihood that you will pick a correct answer? During the quarantine, this is number 3, Sean and Fran have made a game called Where Will the Cat Sit? They have mentally divided the room into a grid of 4 squares by 5 squares, which they have numbered from 1 to 20. It's in my picture here. What's the likelihood that Sean will pick the correct answer of where the cat will sit? And the last one I'm going to give you, actually I'm going to give you 2 more. Oops, not going to give you that one. Oops. No, sorry. This is very unprofessional. I got dogs barking. I can't get my equipment to work right. Okay, number 4. For the game above, Fran notices that the cat rarely sits in the middle of the room. Assuming this is correct, what is the approximate probability that Fran will pick the right square? And my last question, as I hit the 10-minute mark, you flip a coin 3 times. What is the likelihood that you will get 2 of one side and 1 of the other? For instance, heads, tails, or tails, heads, tails. As part of this problem, list out the sample space and then cross out the events that do not match our success criteria. That's all. Ciao.